What is the role of ocean algae with respect to Earth's climate? New discovery reveals that ocean algae unexpectedly help cool the Earth. Hello friends, Jim here. Well, you've heard me discuss this before, but now we're getting more research on this topic. Common type of ocean algae plays a significant role in producing a massively abundant compound that helps cool the Earth's climate, new research has discovered. The findings of the study by the University of East Anglia and Ocean University of China could change our understanding of how these tiny marine organisms impact our planet. The work was published in Nature Microbiology. The team identified the bloom-forming pelagophyceae algae as potentially abundant and important producers of a compound called dimethylsulfonopropionate, or DMSP, which is related to DMS, which is dimethyl sulfide, which is less of a mouthful. Co-lead author Professor Jonathan Todd of UEA's School of Biological Sciences said the pelagophyceae are among the most abundant algae on Earth, yet they were not previously known as important producers of DMSP. This is important because DMSP is an abundant anti-stress compound, food source for other microorganisms, and major source of climate cooling gases. Dr. Jinan Wang of OUC is a PhD student. He's the first author. Understanding the role of pelagophyceae in DMSP production means we need to rethink how much of this compound is being produced and how it impacts the climate. Every year, billions of tons of DMSP are produced in the Earth's oceans by marine microorganisms. Billions of tons. And these releases of DMSP help the organisms survive, by guarding against various stresses such as changes in salinity, changes in temperature, pressure, oxidative stress. Importantly, DMSP is the main source of a climate-active gas called dimethyl sulfide. Hey, there it is, DMS. And DMS gives you that lovely seaside smell that we're all used to. This study suggests that DMSP production and consequently DMS release is likely higher than previously predicted and emphasizes the key role of microbes in regulating global climate. DMS also acts as a signaling molecule, guiding marine organisms to their food and deterring predators. When DMS is released into the atmosphere, DMS oxidation products help form clouds, which reflects sunlight away from the Earth, effectively cooling the planet. So, those people who keep insisting on aerosols and warming stuff up, did you even look at this? Did you factor this into your budget to see what the overall net change, positive or minus, is in sulfur levels and aerosol levels? This natural process is essential for regulating the Earth's climate and is also hugely important for the global sulfur cycle, representing a main route by which sulfur from the ocean goes back to land. So UEA and OUC established the Sino-UK Joint Research Center to promote cutting-edge research and teaching in marine ocean science. UEA's Dr. Andrew Kirsten was a key member, and he identified the novel enzymes responsible for the synthesis of DMSP in diverse bacteria, photosynthetic cyanobacteria, and algae. Dr. Kirsten said, the identity of these enzymes allowed our team to identify pelagophyceae as potentially abundant and important DMSP producers. Co-lead author Professor Xiaoguang Zhang of OUC's College of Marine Life Science added, By identifying the enzymes involved in DMSP production, scientists can better understand and predict the behavior of these ecosystem disruptive brown tide forming algae and their impact on global climate change. This study has also raised questions about other unidentified versions of enzymes needed to make DMSP or entirely different pathways for making it currently unknown. So they need more research into those questions. So they need, some of the things that are needed are better measurements of the environmental DMSP level, production, breakdown rates, and the abundance of the enzymes required to make the DMSP. Do not downplay the role of microorganisms. Do not downplay the role of phytoplankton. Do not play down the role of microbes. They're important. Remember, by biomass, the biomass of prokaryotic organisms is greater than that of eukaryotic organisms. And we know that phytoplankton provide 55 to 80% of atmospheric oxygen, so it shouldn't come as a surprise that phytoplankton and other nearshore groups of microbes release compounds that help form aerosol, that help cool the planet, that help regulate the planet's temperature and climate. In other words, when the planet warms up, more DMSP are released to cool things down, and vice versa. Planet cools down, less of the substance are released, allowing the planet to warm up. In other words, they provide a negative feedback loop, a corrective mechanism to keep the temperature of the planet, the average temperature, somewhat stable. The threat to the phytoplankton is with increasing heat content of the oceans, increasing stratification, decreased mixing, reduction of nutrients, the primary productivity will decrease, which means the DMS levels will decrease, that release to the atmosphere. Now, when in nearshore communities, that's the stratification issue is not really a question. There's plenty of mixing due to tidal action and so on. So you can still expect to see considerable contributions of DMS from organisms located in those areas, in those ecosystems, in those regions. It's a complex question. A lot of data is needed. Exactly how much is produced? How does net destratification impact net primary productivity and the amount released? And how much in total are released from these nearshore organisms? So don't discount these guys. Now, of course, the problem is we're just dumping in so much greenhouse gases that it's most likely overwhelming the capabilities of these organisms, that they can't produce enough DMS to cool things down. They release billions of tons. What's the reduction in aerosols? How many billions of tons is that? So, you've heard me discuss this before. Here it is. Said I don't, it was produced in Nature Microbiology. I don't have a link to that, unfortunately, but very interesting findings, and I hope to start seeing much more research into the DMS question from microbes and phytos. It's an important piece, an important part of the climate puzzle. Until next time, thank you for your time.